Today's objective is the Pythagorean Theorem. Okay, right triangles are very cool because there's a formula to use to find the third side measurement if you only have two of the three side lengths. And the sides also have special names. The two sides that meet at the 90-degree angle are called the legs, right here. Okay, that's the 90-degree angle indicator. And the side opposite the right angle is called the hypotenuse. And this is a kind of fun word to spell because it's made up of a lot of little words. So hy, H-Y, pot, P-O-T, and then use this T to spell 10, T-E-N, and then use, U-S-E. So it's a pretty fun word to spell. So the two sides that meet at the 90-degree angle, because remember the definition of a right triangle is that it has one 90-degree angle. Those are called the legs, and then the side opposite the 90-degree angle, okay, the slanty side, that's called the hypotenuse. So the formula used is called the Pythagorean Theorem because a man named Pythagoras a long time ago discovered this. And what it says is the bottom leg measurement squared plus the side leg measurement squared equals the hypotenuse measurement squared. But that's way too many words. So Pythagoras called the legs A and B and the hypotenuse C. So draw this triangle and draw this one and put in your legs and your hypotenuse, and you can either put the A, B, C up here, or you can write them the A, B, C down here. And this is, you should do a drum roll, the Pythagorean Theorem. A squared plus B squared equals C squared. And notice I color-coded it. And remember that addition is commutative, so you could change the order. So I named this one A and this one B, but you could name this one A and this one B. The legs are called either one. However, the hypotenuse is always C. So you could switch the A and the B. All right, and since this chapter is about exponents and square roots, or even if it wasn't, we know how to solve these problems. So here's a problem. Here's a right triangle. This leg is 8 inches. This leg is 6 inches. And I don't know what the hypotenuse is, so I write in the letter that stands for that. So the question says, find the hypotenuse length. And here are the steps that we will always use using the Pythagorean theorem. You write down the formula. You substitute in your values for A, B, or C, depending which two you have. And then you solve for the missing side. Okay? So I've kind of spaced it out so we can see. So here's my formula, color-coded. A squared plus B squared equals C squared. You can just use a regular pencil. And now we substitute in, since we have the legs, and I had named this A and this B, I'll just do that in that order. So A squared plus B squared, that's A and B, equals C squared. And I keep the variable there because I don't know what that is. Now I do the work. 8 squared is 64, plus 6 squared is 36, equals C squared. 64 plus 36 is 100. So 100 equals C squared. So let's read the note. To solve this, we take the square root, and I wrote the radical around it so you'd remember what that is. However, measurement is always only positive, so there is only one answer. We would not write plus or minus like we did when we were talking about squares and square roots this time. So I rewrote it again, so with the C on the left, because we always like our answer to have the variable on the left. And I wrote C squared equals 100. Then I wrote the square root symbols around it. And remember, you think, what times itself is 100? 10. And what times itself is C squared? C, because that's just the easy part. So the square root of C squared, what times what is C squared? Well, it would be C. So C equals 10. So my measurement up here would be 10. Let's do a couple more. Here I don't know what this leg is, but I know what this leg is and I know what the hypotenuse is. Okay? And it doesn't matter as long as we put our numbers in the right place. That's where kids mess up sometimes, is they always fill in their measurements for the legs, and sometimes it's the hypotenuse. So just pay attention. Write our formula. A squared plus B squared equals C squared. Substitute in what we know. We don't know what A is. A squared plus 3 squared equals 5 squared. Do the math. A squared plus 3 times 3 is 9 equals 5 times 5 is 25. Now before, when we did this problem, since we had A and B, all we had to do was add them together and then take the square root. But here, our variable isn't isolated, so we have to subtract 9, solving equations again from both sides. So A squared equals 16. So now what I would do to solve this is I take the square root of both sides. The square root of A squared is A, and what is the square root of 16? 4. So that means that this leg is 4 inches. Let's do another one. Here I have this leg. I don't have the B leg, but I have the hypotenuse. I write the formula. A squared plus B squared equals C squared. Yes, you have to write it every single time, so you remember it. Substitute in the values we have. We have A and we have C, so I'm going to write 12 squared plus B squared equals 13 squared. And this is why we made the list of all our squared, so you can look at it and memorize some, so you don't have to do a bunch of math. Multiplication, just learn it. So 144 plus B squared equals 169. And just like in this equation, we need to isolate our variable. So we do the inverse operation because we want to make this a zero pair. So 144 minus 144 and minus 144 on this side, this is zero pair. So B squared equals 169 minus 144 is 25. Now how do I solve this? Take the square root of both sides. And what times itself is 25? 5. So this side would be 5 inches. I have just one more thing that I want to show you. I like teaching math because I can say thing all the time, because in English you're not supposed to say thing, you're supposed to be more descriptive. So another thing you can use the Pythagorean Theorem for is to see if 3 side measurements could make a right triangle. For example, I could say, do the sides 5, 8, and 12 form a right triangle? Well, this is what you do. Write the formula. You always have to write the formula. Substitute in the values. And they are always listed in the A, B, C order. So this is A, B, C. Okay, so you never have to worry, well, which is which? Do the math. And do the 2 sides equal each other? If they do, then it's a right triangle. If they don't, it's not. They can't make a right triangle. So here we go. We write our formula, A squared plus B squared equals C squared. We substitute in our A, B, C values. 5 squared plus 8 squared equals 12 squared. We do the math. 5 times 5 is 25. 8 times 8 is 64. 12 times 12 is 144. Now let's add this side together and see if it equals 144. Well, just looking, is 20-something plus 60-something going to equal 144? No. Okay, so you can just look at it and tell. Use your number sense, okay? But let's add it. 5 plus 4 is 9. 2 plus 6 is 8. Does 89 equal 144? No. So no, they could not form a right triangle. Let's do one more. Do 7, 24, and 25 make a right triangle? Notice I just did the symbol instead of the words. I don't know. Those are pretty weird numbers. So let's write our formula down. A squared plus B squared equals C squared. Substitute in the values given in ABC order. So 7 squared plus 24 squared equals 25 squared. This is why we made that list. 7 squared is 49. 24 squared is 576. And 25 squared is 625. Do those equal? Well, they sure look a lot closer than the other problems. So let's add. 9 plus 6 is 15. Carry the 1. Make that a 5. 5 plus 7 is 12. Carry the 1. 6. Oh, 625 equals 625. So since the A squared plus the B squared equals the C squared, then yes, these sides would make a right triangle. And when you have 3 whole numbers as the 3 sides on a right triangle, it's pretty special because most have decimals. You take the square root and it'll be a number that doesn't repeat and goes on forever. So these three whole numbers are called Pythagorean triples. And some examples are the problems that we've done today. The side measurements 3, 4, 5. Now times each by 2. 6, 8, 10. Also 5, 12, 13. And you could times those numbers by 2, 3, and 4, and they would be just bigger right triangles. 7, 24, 25, like we did here. And there are a lot more. And that's it.